Planet X, the ninth planet? Astronomers say a Neptune-sized planet does lurk beyond Pluto. This is from Science Magazine, Eric Hand, Unbended Reality. The solar system appears to have a new ninth planet, and today two scientists announced evidence that a body nearly the size of Neptune, but as yet unseen, orbits the Sun every 15,000 years. During the solar system's infancy 4.5 billion years ago, they said, the giant planet was knocked out of the planet-forming region near the Sun. Slowed down by gas, the planet settled into a distant elliptical orbit where it still lurks today. The claim is the strongest yet in the centuries-old search for a Planet X beyond Neptune. The quest has been plagued by far-fetched claims and even outright quackery. But the new evidence comes from a pair of respected planetary scientists, Konstantin Batygin and Mike Brown of the California Institute of Technology, Caltech in Pasadena, who prepared for the inevitable skepticism with detailed analysis of the orbits of other distant objects and months of computer simulations. Quote, if you say we have evidence for Planet X, almost any astronomer will say, this again? These guys are really clearly crazy. I would too, Brown says. Why is this different? This is different because this time we're right, he said. Outside scientists say their calculations stack up and express a mixture of caution and excitement about the result. Quote, I could not imagine a bigger deal if, and of course that's the boldface if it turns out to be right, end quote, says Gregory Lawlin, planetary scientist at the University of California, Santa Cruz. He says what's thrilling about it is the planet is detectable. Batygin and Brown inferred its presence from the peculiar clustering of 6 previously known objects that orbit beyond Neptune. They say there's only a 0.007% chance, or about 1 in 15,000, that the clustering could be a coincidence. Instead, they say a planet with a mass of 10 Earths has shepherded the 6 objects into their strange elliptical orbits, tilted out of the plane of the solar system. The orbit of the inferred planet is similarly tilted, as well as stretched to distances that will explode previous conceptions of the solar system. Its closest approach to the Sun is 7 times farther than Neptune, or 200 astronomical units. An AU is the distance between the Earth and the Sun, about 150 million kilometers, that's 92 million miles. And Planet X could roam as far as 600 to 1,200 AU, well beyond the Kuiper Belt, the region of small icy worlds that begins at Neptune's edge about 30 AU. So if Planet X is out there, Brown and Batygin say, astronomers ought to find more objects in telltale orbits shaped by the pull of the hidden giant. But Brown knows that no one will really believe in the discovery until Planet X itself appears within a telescope viewfinder. Quote, until there's a direct detection, it's a hypothesis, even a potential very good hypothesis. This is what he says. And the team has time on the one large telescope in Hawaii that is suited for such a search, and they hope other astronomers will join in the hunt. Mike Brown from Caltech says, killing Pluto was fun, but this is head and shoulders above everything else. Batygin and Brown published the result in an astronomical journal. Alessandro Morbidelli, a planetary dynamicist at the Nice Observatory in France, performed the peer review of the paper. In a statement, he said Batygin and Brown made a very solid argument and that he is quite convinced by the existence of a distant planet. Championing a new ninth planet is an ironic role for Brown. He's better known as a planet slayer. His 2005 discovery of Eris, that is, E-R-I-S, a remote icy world nearly the size of Pluto, revealed that what was seen as the outermost planet was just one of many worlds in the Kuiper Belt. Astronomers promptly reclassified Pluto as a dwarf planet, a saga Brown recounted in his book, How I Killed Pluto. Now he was joined the centuries-old search for new planets as his method inferring the existence of Planet X, or Nibiru, or Planet 10, Planet X, from its ghostly gravitational effects, has a respectable track record. In 1846, for example, the French mathematician Urbain Le Verrier predicted the existence of a giant planet from irregularities in the orbit of Uranus. Astronomers at the Berlin Observatory found the new planet Neptune, where it was supposed to be, sparking a media sensation. Remaining hiccups in Uranus's orbit led scientists to think that there might yet be one more planet out there, and in 1906, Percival Lowell, a wealthy tycoon, began the search for what he called Planet X at his new observatory at Flagstaff, Arizona. In 1930, Pluto turned up, but it was far too small to tug meaningfully on Uranus. More than half a century later, new calculations based on measurements by the Voyager spacecraft revealed that the orbits of Uranus and Neptune were just fine on their own. No Planet X was needed. Yet the allure of Planet X persisted. In the 1980s, for example, researchers proposed that an unseen brown dwarf star could cause periodic extinctions on Earth. Okay, this is important. Could cause periodic extinctions on Earth by triggering fusillades of comets. And in the 1990s, scientists invoked a Jupiter-sized planet at the solar system's edge to explain the origin of certain oddball comets. Just last month, researchers claimed to have detected the faint microwave glow of an outsized rocket planet some 300 AU away using an array of telescope dishes in Chile called the Atacama Large Millimeter Array, or ALMA for short. Brown was one of many skeptics, noting that ALMA's narrow field of view made the chances of finding such an object vanishingly slim. Brown got his first inkling of his current quarry in 2003 when he led a team that found Sedna, an object a bit smaller than both Eris and Pluto. Sedna's odd, far-flung orbit made it the most distant known object in the solar system at the time. Its perihelion, or closest point to the Sun, lay at 76 AU, beyond the Kuiper Belt and far outside the influence of Neptune's gravity. The implication was clear. Something massive, well beyond Neptune, must have pulled Sedna into its distant orbits. That something did not have to be a planet. Sedna's gravitational nudge could have come from a passing star, or from one of the many other stellar nurseries that surround the nascent Sun at the time of the solar system's formation. Since then, a handful of other icy objects have turned up in similar orbits. By combining Sedna with 5 other weirdos, Brown says he has ruled out stars as the unseen influence. Only a planet could explain such large, strange orbits. Of his 3 major discoveries, Eris, Sedna, and now potentially Planet X, Brown says the last is the most sensational. He said, killing Pluto was fun, finding Sedna was scientifically interesting, but this is head and shoulders above everything else. Brown and Battigan were nearly beaten to the punch. For years, Sedna was a lone clue to a perturbation from beyond Neptune. And then in 2014, Scott Shepard and Chad Trujillo, a former graduate student of Brown's, published a paper describing the discovery of VP 113, another object that never comes close to the Sun. Shepard of the Carnegie Institute of Space of Science in Washington, D.C., and Trujillo of the Gemini Observatory in Hawaii were well aware of the implications. They began to examine the orbits of 2 objects along with 10 other oddballs. They noticed that at perihelion all came very near the plane of solar system in which Earth's orbit called the ecliptic, and in the paper Shepard and Trujillo pointed out the peculiar clumping and raised the possibility that a distant large planet had herded the objects near the ecliptic, but they didn't press the result any further. And later that year, at Caltech, Battigan and Brown began discussing the results, plotting the orbits of the distant objects. Battigan says they realized that the pattern that Shepard and Trujillo had noticed, quote, was only half of the story, end quote. Not only were the objects near the ecliptic at perihelia, but their perihelia were physically clustered in space. For the next year, the duo secretly discussed the pattern and what it meant. It was an essay relationship, and their skills complemented each other. Badigan, 29-year-old whiz-kid computer modeler, went to college at UC Santa Cruz for the beach and the chance to play in a rock band, but he made his mark there by modeling the fate of the solar system over billions of years, showing that in rare cases it was unstable. Mercury may plunge into the sun or collide with Venus. Quote, "It was an amazing accomplishment for the undergraduate," says Lawlin, who worked with him at the time. Brown, 50 years old, is the observational astronomer with a flair for dramatic discoveries and the confidence to match. He wears shorts and sandals to work, puts his feet up on his desk, and has a breeziness that makes intensity and ambition. It masks intensity and ambition. He has a program all set to sift for Planet X and data from a major telescope the moment they become publicly available, and their offices are a few doors down from each other. Quote, "My couch is nicer, so we tend to talk more in my office," Badigan says. "We tend to look more at data in mics." They even became exercise buddies. Discussed their ideas while waiting to get in the water at Los Angeles, California triathlon in the spring of 2015. First, they winnowed the dozen objects studied by Shepard and Trujillo to the six most distant, discovered by 6 different surveys on 6 different telescopes. That made it less likely that the clumping might be due to an observation bias such as pointing a telescope at a particular part of the sky. Badigan began seeding his solar system models with planet X's of various sizes and orbits to see which version best explained the object's paths. Some of the computer runs took months, and favorite size for planet X emerged, and this was between 5 and 15 Earth masses, as well as a preferred orbit, anti-aligned in space from the 6 small objects so that its perihelion is the same direction as the 6 objects' aphelion, or the farthest point from the sun. The orbits of the 6 cross that of planet X, but not when the big bully is nearby and could disrupt them. The final epiphany came a little while ago when Badigan's simulations showed that planet X should also sculpt the orbits of objects that swoop into the solar system from above and below, nearly orthogonal to the ecliptic. Brown said, "It sparked this memory. I had seen these objects before." It turns out that since 2002, 5 of these highly inclined Kuiper Belt objects have been discovered, and their origins are likely largely unexplained. Quote, "Not only are they there, but they are in exactly the places we predicted," Brown said. And he said, "That is when I realized that this is not just an interesting and good idea, this is actually real," end quote. Shepard, who with Trujillo had also suspected an unseen planet, says Badigan and Brown, took our results to the next level. They got deep into the dynamics, something that Chad and I aren't really good with. That's why I think this is exciting. Others, like planetary scientist Dave Jewett, who discovered the Kuiper Belt, are more cautious that the 0.007% chance that the clusters of the 6 objects is coincidental gives the planet claim a statistical significance of 3.8 sigma, beyond the 3 sigma threshold typically required to be taken seriously, but short of the 5 sigma that is sometimes used in fields like particle physics. That worries Jewett, who has seen plenty of 3 sigma results disappear before. By reducing the dozen objects examined by Shepard and Trujillo to 6 for their analysis, Badigan and Brown weakened their claim. He says, "I worry that the finding of the single new object that is not in the group will destroy the whole edifice," says Jewett, who is at UC Los Angeles. He says it's a game of sticks with only 6 sticks. At first blush, another potential problem comes from NASA's Wide Field Infrared Survey Explorer, or WISE telescope, a satellite that completed an all-sky survey looking for the heat of brown dwarfs, or giant planets. It ruled out the existence of a Saturn or larger planet as far out as 10,000 AU, according to a 2013 study by Kevin Luhman, an astronomer at Pennsylvania State University Park. But Luhman notes that if planet X is Neptune-sized or smaller, as Badigan and Brown say, Wise would have missed it. He says there is a slim chance of detection in otherwise data set at longer wavelengths, sensitive to cooler radiation, which was collected for 20% of the sky. Lumen is now analyzing those data. Now, even if Badigan and Brown can convince other astronomers that Planet X exists, they face another challenge, explaining how it ended up so far from the Sun. At such distances, the protoplanetary disk of dust and gas was likely to have been too thin to fuel planet growth. And even if Planet X did get a foothold as a planetesimal, it would have moved too slowly in its vast, lazy orbit to hoover up enough material to become a giant. And instead, Badigan and Brown proposed that Planet X formed much closer to the Sun, alongside Jupiter, Saturn, Uranus, and Neptune. Computer models have shown that the early solar system was a tumultuous billiards table with dozens or even hundreds of planetary building blocks the size of Earth bouncing around. Another embryonic giant planet could easily have formed there, only to be booted outward by gravitational kick from another gas giant. It's hard to explain why Planet X didn't either loop back around to where it started or leave the solar system entirely. But Badigan says that residual gas in the protoplanetary disk might have exerted enough drag to slow the planet just enough for it to settle into a distant orbit and remain in the solar system. That could have happened if the ejection took place when the solar system was between 3 million and 10 million years old, he says, million years, yes, before all the gas in the disk was lost into space. Hal Levison, a planetary dynamicist at the Southwest Research Institute in Boulder, Colorado, agrees that something has to be creating the orbital alignment Badigan and Brown have detected. But he says the origin story we have developed for Planet X and their special pleading for a gas-slowed ejection add up to a low probability event. Other researchers are more positive. The proposed scenario is plausible, Lawlin says. Usually, things like this are wrong, but I'm really excited about this one, he says. It's better than a coin flip. All this means that Planet X will remain in limbo until it's actually found. Astronomers have some good ideas about where to look, but spotting the new planet won't be easy because objects in highly elliptical orbits move fastest when they are close to the Sun. Planet X spends very little time at 200 AU, and if it were there right now, Brown says, it would be so bright that astronomers probably would have already spotted it. Instead, Planet X is likely to spend most of its time near aphelion, slowly trotting along at distances between 600 and 1200 AU. Most telescopes capable of seeing a dim object at such distance, such as the Hubble Space Telescope or the 10-meter Keck telescope in Hawaii, have extremely tiny fields of view, and it would be like looking for a needle in a haystack by peering through a drinking straw. One telescope can help. Subaru, an 8-meter telescope in Hawaii that is owned by Japan. It has enough light gathering area to detect such a faint object, coupled with a huge field of view, 75 times larger than that of the Keck telescope. That allows astronomers to scan large swaths of the sky each night. Badigan and Brown are using Subaru to look for Planet X, and they are coordinating their efforts with their erstwhile competitors, Shepard and Trujillo, who have also joined the hunt with Subaru. Brown says it will take about 5 years for the two teams to search most of the area where Planet X could be lurking. And if the search pans out, what should the new member of the Sun's family be called? Brown says it's too early to worry about that and scrupulously avoids offering up suggestions. For now, he and Badigan are calling it Planet 9, and for the past year informally Planet Fatty, 1990s slang for cool. Brown notes that neither Uranus nor Neptune, the two planets discovered in modern times, ended up being named by their discoverers, and he thinks that that's probably a good thing. It's bigger than any one person, he says. It's kind of like finding a new continent on Earth. He's sure, however, that Planet X, unlike Pluto, deserves to be called a planet, something the size of Neptune in the solar system. Don't even ask. No one would argue this one, not even me, he said. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.